but they're very good at it. So their job is done, and so now all 18 mirrors are finished, polished, and coated, and almost all are completely tested. So in about a year, we have all of them at Goddard, I think. We built a little practice telescope this big because we wanted to know if we'd be able to focus. Well, people did sort of notice that the Hubble telescope was not in focus after it was launched. And we had no end of public ribbing about this, and people draw pictures of the space shuttle with a jump start battery by it and things like this. So we figured we better get this right. So we will be able to focus the telescope after launch. And all of those mirrors that I showed you are adjustable. They have little motors on them. In fact, each one has 7 motors, so that we can make sure they're properly positioned. They couldn't possibly be focused when we launch it because it's not even unfolded yet. So this is another amazing mechanical engineering result. We can do this. Here's a story about probably our most complicated instrument. It comes from Europe. It's called a NearInfrared Spectrograph. The optical bench, all the mechanical structure, and all the mirrors are made out of silicon carbide, which you think of as a grinding stone material. In Europe, it's a useful space-age material. You can make this stuff. It's almost as hard as diamond. It's very strong, very stiff, and rather brittle, so it's tricky to use, but that's what they decided to do. And curiously enough, when everything's of the same material, when you cool it down to a low temperature, it all stays in focus. That's pretty good. So another amazing thing this can do is it has an amazing array of little shutters, little windows that open up like those windows on the Advent calendars when you want to see the saints come out. We can open up, we have 250,000 windows for the light for the galaxies to come in. And then it goes on to the spectrometer and we take the pictures. A little picture of the micro shutters. These are actually made in the labs at Goddard Space Flight Center. So it's micro electromechanical stuff. They're actuated by magnetic fields and electric fields, and totally amazing. So if you need one of those, they're pretty hard to come by, but we do have the recipe. This is the giant clean room at Goddard. Some of you have been to see us. There's a huge glass window where you can look through where the Hubble repair was rehearsed. We had astronauts in there. We've taken all the Hubble stuff out, and we're starting to put in the James Webb Space Telescope equipment. As of today, they are beginning to prepare the assembly of the telescope. There's a huge structure that's as high as this room, which we have to put the segments onto the primary mirror structure. So that's coming in, will be in place by Christmas. Another thing we have to do to make sure we're in focus when we fly is test it. This is a test that the Hubble Space Telescope program decided they couldn't afford. Well, we couldn't afford it either, but we had to have it anyway. So that's one of the reasons our budget has gone up compared with what we had before. This is the test chamber at Johnson Space Flight Center where the Apollo astronauts rehearsed landing on the moon. So it's huge. It's 120 feet high, 65 feet in diameter, and now we are putting in cooling facilities so it will get down to the temperature that the telescope will have in outer space. So in a few years we'll be down there putting it together again, making sure that it does focus. Now just a few things to show you about the early universe. Just as what are the scientific results we hope to get. This is a simulation of the formation of galaxies. It is claimed that we now know the beginning because we made the measurements with the COBE satellite and other things. Now we can say, okay, computer, tell me how that might have looked. So this is the formation of galaxies as seen through a cosmic weather simulator. Put in all the laws of nature that you know and see what happens. So you see these galaxies forming by absorbing their neighbors. And it's pretty chaotic and pretty beautiful. This is something that might be true and might not. It gives us much more detail than we'll ever be able to see with a telescope, but we should actually be able to tell eventually if the general idea is correct. If we left out of any basic theories, if we didn't know how clouds form, we wouldn't get the right answer. So anyway, it is possible to simulate. I think 10 billion particles were simulated in this giant supercomputer thing. Then another one to show you, this is something that could happen to us. This is the collision of two galaxies of about equal size. The Andromeda nebula coming toward us in a few billion years might happen like this. As the particular simulation shows, they miss. They don't collide head-on. But these giant strings of stars are pulled out. Now, since the sun is on the outside edge, not close to the middle of our galaxy, we might be among those that are just thrown out into outer space. We don't know. But at any rate, we do see galaxies colliding out there. This is not a thing that we can't check. We can find out by observing, and we already can sort of tell from the Hubble Space Telescope whether this is actually something like what will happen to us. So you see they're merging together, and there are these huge streams of stars that have been expelled. Could be us.
What is the time constant?
Oh, how long is this taking? This is hundreds of millions of years for this event. Many hundreds. It takes us about 200 million years to go around the center of our own galaxy, so that sort of tells you the scale. Just a few other wonderful things to tease you about. I told you that gravitation bends light. We've seen it. See that little pink arc in the upper right corner of this picture? That's a distant galaxy. It's been magnified by the gravitational forces of those other galaxies that are in that beautiful picture. So nature has given us an extra lens in our telescope to help us see farther. Of course, nature didn't know it was planning for us, but it's there, and so we use them. And about several hundred of these cosmic lenses are known, where little tiny galaxies from very, very, very early can be magnified enough for us to see them. So we'll be doing that on purpose. Oh, once in a while a star blows up, actually pretty often. Once in a while they have a jet of material that comes out near the speed of light. And once in a while that jet of material is aimed at us. And when that happens, we can see this event all the way across to almost the edge of the universe. And these were discovered by trying to find out if the Soviet Union was cheating on the test ban treaty. And we put up this network of gamma ray observing satellites, and they said, you know, something's happening out there several times a day, something's going off. But it wasn't the Russians. So it took something like 40 years to find out what they really are and to prove that they're really as far away as they are. Scientists didn't want this to be true. We couldn't understand how a star could do this. But it is. We will be able to see inside beautiful clouds like this. This is where Hubble Observatory showed us a picture of stars that have just been born, lighting up this beautiful cloud of dust and gas. We know from a picture taken from the ground that you can see through the dust and see inside. Same place, seen with infrared. But this is a blurry picture taken from the ground. We want to go up and take a better picture from outer space, and we'll be able to see inside the nurseries where stars are being born today. This was another surprise of astronomy. 50 years ago, people didn't know yet that stars weren't all formed at the same time at the beginning. It took us a while to appreciate this. We're kind of slow thinkers, I think. But at any rate, the picture on the left and the picture on the right are the same place, taken with Hubble. The one on the right is taken with infrared, and you can see inside where this star is making itself. Planets. We can do planets. Hubble Space Telescope has actually taken made the first discovery of a planet where the position was predicted since the discovery of Neptune. The observation said, we see this little ring of dust orbiting around this star. It's pulled off center. There has to be a reason. The planet should be over there. And sure enough, they looked and it was there. And they looked again 2 years later and it had moved just like it should. So now we have seen a planet around another star with the Hubble Space Telescope. The other two pictures there also show things that with rather advanced optics, we can do similar tricks from the ground. So we've seen some super mega planets orbiting around stars around quite a few places now. So one of our upcoming tricks and one of the current tricks going on is to observe planets that what we call transit. A planet will go between us and the star that it's orbiting around. And for a little while, it'll block some starlight. And we'll say, why did that star get fainter? Oh, it's because a planet went by. And some of these can be even seen from the ground. I met a young college student who discovered some for his college astronomy course. So it's possible to do. Once in a while, the planet will go behind the star, and if the planet is bright enough, you'll notice that the combination gets fainter also. So this is a wonderful technique. It's been done with telescopes in space, with telescopes on the ground, and the cool thing about it for us is a little bit of the starlight goes through the planetary atmosphere on its way to the telescope. So now you can say, well, does the planet have clouds? Does it have water? Does it have oxygen? What does it have? So we've already been able to discover molecules in the atmospheres of planets around other stars, exoplanets. So we have even now a catalog of 1,235 such objects that were measured by the Kepler Observatory over the last couple of years. So we know where to look. And some of them might be a little bit Earth-like. If we're lucky, we have a small star in a large version of Earth, we may be able to tell that it has a liquid water surface. That would be wonderful. We might be able to tell it has a satellite, even. So a lot of excitement about this subject. You probably heard a couple of weeks ago they found from one of the Kepler Observatory catalogs a little planet going around a double star, a binary star. And apparently this is in, is it Star Wars that it's in? Tatooine is the name of this hypothetical planet. Anyway, found one. That's wonderful. So, just to say, astronomers don't always have to go out of the solar system to look for cool stuff. There are a few places on besides Mars and Earth which are possibly alive in the solar system. This is a picture of one of them. This is Europa. It's a satellite of Jupiter. Galileo discovered it in 1609. And we sent an observatory called Galileo to go have a look and took this picture. And you see what we saw is the surface is covered with ice. And there's cracks in the ice. And there's an ocean under that ice. And mud is coming up in the cracks from time to time. So it's a fascinating place for astronomers, and we would just love to know if the ocean is alive underneath. We may not ever find out, because that's a really, really hard problem. This is an extremely hostile place to go, but it doesn't mean it's not alive. So we would just really be thrilled if we could know this answer. It's probably easier to find out if Mars is alive, and so later this year we're launching a science lab to land on Mars, and maybe we'll find out sooner rather than later that it's alive. That's tricky. So anyway, that's the end of my story, except maybe one more chart. Just some places you can learn more. We have James Webb Space Telescope website. There's one for cosmology called Lambda. The NobelPrize.org website is really great. You can go there to find out what they announced today, why it was important. And I even have a little book that was a paperback published a few years back called The Very First Light. Last I looked, it was 87 cents or something from Amazon. So I'm sorry, I forgot to bring some. But anyway, it's the story of the COBE and cosmology. So thanks very much for the invitation to come, and if we have a few minutes, I'll be happy to answer people's questions.